The previous part of this video got cut off, so this is me redoing the last question and the last part of the penultimate question. So, when the train begins its journey, it accelerates uniformly at 1.081 recurring meters per second. Write the acceleration as a mixed number in its simplest form. So for this, what I'd like to do is write x is equal to 0.8181. And then we need to move the decimal point so that the second recurrence of the 81 is just after the decimal point. And to do that, we have to times it by 1,000. So we have 1,000x is equal to 1,081.81. And I also need to times it by 10 so that the first recurrence of the decimal is right after the decimal point. So we have 10 times x is 10.81. If I take these two away from each other, what we end up with is 990x is equal to 1071. This means x is equal to 1071 over 990. To put it into a proper fraction, there's 990 in 1071. Remained 81 over 990. 81 and 990 are divisible by 9. So 81, 9 into 81 goes 9 times. 9 into 990 goes 110 times. And that's the answer. Final question. Safety Cones is a company that makes traffic cones. Its traffic cones have a base that is shaped of an octagon prism with a hollow cone shape sitting on the top of the base. The bases of the traffic cone are symmetrical and have a circular hole in them, allowing the cones to be stacked. And there's a picture of a cone. The dimensions of the octagon base are shown below and the height is 5 centimeters. The cone that sits on top of the octagon base is shown below. It has a height of 60 centimeters and a circular base area of 800 centimeters squared. Gary is transporting a stack of 10 cones in the back of a van. Calculate the volume of space that the stack of 10 cones takes up in the back of Gary's van. Give your answer in centimeters cubed. You should assume that the space taken up includes the space underneath the bottom of the cone and any gaps between the cone. Okay, so let's do volume of the actual cone first. So the volume of a cone is 1/3 pi r squared times the height. So we have the third. We know the height of the cone is 60 centimeters, and we're going to be timesing this by pi r squared. But notice that's the area of a circle, so that's the base of the cone, which we know is 800. So we can cancel that 3 and cancel that 6 to give 20. So this would give 16,000 centimeters cubed. We now have to worry about the base. So this base can be divided into two identical trapeziums and a rectangle. We can calculate the volume, the area of that, and then times it by the height of the stack. So if we start off with the base area, so this is going to be 50 times 20, which is the rectangle, which is 1,000 centimeters squared. And then we got the trapeziums, but there's going to be two of them, so we're going to be doing 2 times 1/2, and then we got the sum of the parallel sides, which is 20 and 50, times the height of one of the trapeziums, which is going to be 50 minus 20, which is 30, divided by 2, which is 15. So this 2 will cancel with this 2. So effectively we have 70 times 15. 70 times 10 is 700. 5 times 70 is 350. Add the 2 together. Not sure what happened there. Add the 2 together gives 1,050. So if we total those two areas, that gives us 2,250. And then the height of the base is equal to 5 times 10, which is 50. So we got 2,000 and 50 times by 50. So that's going to be 0, 0, 0, 0, 0, 0, 5, carry the 2, so we got 5 carry the 2, 5 times 0 is 2, and then we've got another 5 times 10. So this is our volume of the base. And then we just need to add that to the 1600. So we got total volume, which I'll just write as total V, is going to be 118,500 centimeters cubed. Anyway, make sure you hit the subscribe button, and I'll see you for another maths help very soon.